The law of refraction tells us about what happens to light when it goes from one material into another. The optical density of the two materials is different. It's possible for the light to actually change direction in terms of where it's going. In this tutorial, we'll show you how you can determine what direction light's going to go when it travels from one material into another. Here, light is traveling from this laser in air, right? Traveling toward the water surface and then going into water. And then we also see some reflection. This tutorial is going to focus on the refracted water, which is the water that's bouncing down into the water. To set up our equality, Snell's law tells us that the index of refraction of one material times the sine of the angle that the light makes in that material is actually constant. So when it goes from air into water, that product of the index of refraction of water times the sine of the angle it makes in the water actually stays the same as what it was in air. So in air, the index of refraction is 1.0, right, which is noted over here. We have to determine what angle the light is actually making in air before we can go to the next step. To do that, at the intersection between the two materials and where the light hits, we have to draw a normal line. A normal line is just a line that's perpendicular to the interface between the two surfaces. That's 90 degrees. From there, we can make the measure of the angle between the light ray and that normal line. In this case, this is about 75 degrees. So in that case, this here becomes 1.0 sine 75 degrees. Then we only need to do the same thing for the other side here. The index of refraction of water is 1.33. And then we have to do the same thing. We have to make a measure of the angle that the light makes in the water. But in this case, we can actually solve for it because we have everything else in this model. 1.33 sine of the angle that it makes in the water. If we go to the mathematics here, we would divide both sides by 1.33. That leaves us with the sine of the angle in the water. And that would be some sort of number based on whatever that turns out to be. And then if you take the inverse sine of both sides, we end up with that coming out to be about 45 degrees or so.